Hello and welcome to R&D Mathematics. Today we are going to talk about operations of functions. Operations on the functions. Now, first the summation. Sum of two functions we denote it by f plus g of x. This is basically f of x plus g of x. And the domain, this is the thing that you must learn. Domain is going to be domain of f intersection domain of g. And difference. That's f minus g. This is the notation, but that means simply f of x minus g of x. And the domain d of f, again intersection d of g. Now I'll explain these things after I finish writing. Then product. Product f times g, f times g small dot x. That means simply f of x times gx. Now remember guys, there is another operation that we will be learning in next video, f circle g, or composition of f and g, and that's a different story. It's not the product, right? So that's a different story. Now again the domain is the same, intersection d of g. Finally, quotient, that means division. Notation f over g of x, which simply means f of x over g of x. Now what you need to learn here, actually, this part right here, it's new notation. And this part right here, it's quite understandable, right? So you add two functions, you subtract two functions, you multiply two functions, and you divide two functions. And finally, the domain of this guy, domain of f, domain of g, one more thing, intersection, places where g not equals to 0. Now I'll explain this. I'll explain all this by using some examples. Now let's take some examples. Let's say if we have f of x equal square root of x plus 3 and g of x equal square root of 1 minus x. Now, first of all, see, in order to find the domain of all these functions, we will need domain of f and g separately. So let's find domain of f and g separately. First, domain of f and g separately. Domain of f is, we take the radical and make it greater than or equal to 0, and we get this. So in number line somewhere here, -3, x is greater than -3, so to this side, -3 to infinity. And domain of g, 1 minus x, we set it greater than 0, so we get x is less than 1. So 1 is somewhere here, everything to the left, so negative infinity all the way up to 1, right? Now f plus x, sorry, f plus g of x, that is simply f of x plus g of x with our definition. So you have x plus 3 and then square root of 1 minus x, and that's pretty much it. You cannot do anything, right? If you can add, there are like terms, you have to simplify it, but in this case that's pretty much it. And the domain of f plus g, the new function, is intersection of these two domains. So if you think about it, intersection of -3 to infinity, intersection negative infinity to 1, that means if you draw these two in one common, let me draw it over here. So one part, -3 is somewhere here, 1 is somewhere here. So from here we have up to this, and from this other one we have this. So the common part, if I use another color, is this part, right? Including those two endpoints. So this is -3 to 1. That is the domain. Now the reason, now let me go back, reason why these things behave like that, because the new function, this new function is a combination of these two functions, so we must have a common ground, right? So in our example, f only works in this region. That's a pretty big region, but g only works in this region. Because of that, f plus g, this new function only works in this small region. I hope that's understandable, and I leave it as an exercise for you guys to figure out f minus g and f minus g is easy. Let me do f times g, f of x times g of x. Again, you just multiply them pretty much. 1 minus x. Well, in this case, you can actually take both of them into the side of our square root sign, and it's going to be, if you multiply, well, you can leave it like that, or you can simply expand it. So I'll just leave it like that, because, and the domain for this guy and this guy is still going to be this. But how about f over g? Now f over g, this one again, f of x, which is x plus 3 divided by 1 minus x. This is it. You cannot do pretty much anything about that. This is it. But in cases where you can simplify, go ahead and simplify, right? Or you can put them all together inside one and write it like this. But what I'm going to, the most interesting thing is the domain. Let me write it over here. It's in another color. How about white? So domain of f over g, exactly like what we got for these three guys was -3 to 1. Same domain, except you had to be careful, except get rid of the places where your denominator is 0. So obviously that's what it says in this sentence. So you take domain of f, you take domain of g, common part, and then only the places where g is not 0, or in other words, where g is 0, you exclude them. So what you need to do, basically look at this place. When x is 1, denominator is 0, so here 1 is a problem. So the domain is -3 to 1, not including 1. That is the only difference. And that's pretty much it for operations on functions. That's not that hard one. And in our next video, we are going to talk about f circle g, or composition of functions. That's going to be interesting. Thank you.